Hello and welcome to our presentation on our comparative study on gait kinematics between barefoot subjects and subjects wearing shoes. The development of minimalist barefoot technology, also known as MBFT, has been inspired by the recent and renewed movement in barefoot running. A popular book titled Born to Run recounts the story of Mexico's Tarahumara Indians who are known to run 100 miles or more at a stretch without the use of traditional athletic footwear. The book hints towards the overly complicated ruse of traditional footwear technology and further insinuates that these technologies may even be bad for runners' feet. The alternative technology of minimalist barefoot technologies has a focus on being extremely light and flexible, having a low heel and toe drop, and having little to no cushioning to closely replicate the barefoot running experience, however with heightened safety. Concerningly, however, the effectiveness of MBFT technology is not a foolproof technology, with studies supporting and discarding its capabilities. A study that involved elderly women suffering from knee osteoarthritis found that moment impulse was reduced in the knee joint and enhanced trunk activities in healthy populations when wearing MBFT shoes. Alternatively, negative effects such as higher vertical forces of MBFT shoe walking has been observed. Additionally, running in MBFT shoes increases forces on the lower extremities, knee flexion and dorsiflexion angle, average vertical component of ground reaction forces, and the force on the Achilles tendon. Walking barefoot leads to poorer symmetry when compared to neutral running shoes in the ankle joint force in sagittal plane, knee joint moment in transverse plane, and ankle joint moment in frontal plane. However, it has better symmetry of the joint angle in the sagittal plane at the ankle and global positions. MBFT shoes, however, show an intermediate gait symmetry performance in comparison to the barefoot and neutral running shoes, which has led to the belief that MBFT technologies may be an ideal compromise for those who wish to have a walking or running experience that mimics the results of barefoot gait.
The paper we reviewed is full-step psychokinematic and kinetic comparison of barefoot walking and a traditional shoe walking in healthy youngs. Insights for barefoot technology. This paper aims to compare, investigate, and provide insight into the comparison of barefoot walking to those of unnatural shoe walking in a healthy young population. There were 28 volunteers, consisting of 22 female and 6 males. All volunteers walked along a 10-meter walkway, both barefoot and wearing natural running shoes at their comfortable walking pace. All subjects wore a set of markers which was used to collect their data from their walking trials. The power and moment of hip, knee, and ankle joint data was recorded and future analyzed. 5 trials of each were conducted, with the walking trials randomized. In analyzing the data, only trials with similar walking speed were analyzed. From analyzing the results, regular running shoe was able to reduce load and joint angle on the lower body in early stages. Barefoot walking resulted in decreased hip and knee moment, as well as decrease in power of knee, hip, and ankle. Wearing regular running shoe or walking barefoot each had their respective merits, and that we should not so quickly discard regular running shoe design as we move to embrace MBFT shoes. Our experiment to replicate the process and the result from this publicated journal article on comparisons between barefoot walking and traditional shoes walking in youngs. We have a hypothesis that walking with traditional natural running shoes can significantly reduce the load and joint angle for the lower extremity. Running shoes will also be more effective than walking barefoot at the early stage phase.
In our experiment, 2 able-bodied male university students volunteered for this study. All the tests were conducted at a motion lab in Neura using a Nexus motion capture system. This system used 8 infrared cameras to track 16 reflective markers on the lower body. A force plate located in the center of the room was used to record ground reaction forces. This data was transmitted to a computer and analyzed by Nexus software. All kinematic and kinetic data was then analyzed. Full measurements of both subjects were initially taken before the placement of markers and walking trials. Accurate anthropometric measurements, including body mass, height, Ankle width, knee width, and leg length were taken for each participant, as well as the height of their shoe. A plug-in gait lower body model was used in the marker location. Each participant had a total of 16 markers placed on the iliac spine, thigh, knee, tibia, ankle, heel, and toe. A profile for each subject was created and calibrated in Nexus for each condition. Both subjects were required to walk along the pathway 5 times while barefoot, ensuring that the right foot stepped onto the force plate for each walk, walking at a comfortable walking pace. This was repeated with the participants wearing running shoes. The measured data was transmitted, processed, and analyzed using the Nexus software. Then these kinematic and kinetic results, including joint angles, powers, moments, and reaction forces for hip, knee, and ankle, were exported by Mocha. MATLAB was used to calculate the average results of each subject, and OpenSim was used for the walking simulation and animation.
Here is our OpenSim animation. Two male university students participated in our experiment, and here are their answer parametrics. Subjects' height, width, and result shoes were measured separately. Compared gait variables, we found that our two subjects' both step length and walking speed of barefoot are slightly less than their straight lines and pace with shoes. However, when they walk with shoes, the cadence is slower than their barefoot cadence. The p-value of straight lines is 0.017, and the cadence is 0.036. Therefore, there are significant differences when our subjects walk with shoes or not. This figure shows many obvious differences between wearing shoes and barefoot of subject 1. The moment of subject wearing shoes is less than the barefoot moment at the early stance of knee moment and pre-swing of ankle moment. This subject spent more vertical ankle joint reaction force at the early stance and the pre-swing phase. Barefoot flexion angles of hip and knee are still smaller than angles of subject wearing shoes in the swing phase, while the barefoot ankle angles is smaller than at early stance and the initial swing, and then it increases rapidly to greater than ankle angle when the subject wearing shoes. This figure indicates the same and consistent result. When subject 2 walks with shoes, the magnitude of hip moment, knee moment, ankle moment, and the magnitude of hip power, knee power is all less than the magnitude of barefoot moment and power in the swing phase. The bottom of barefoot ankle angles are a little bit lower than the subject wearing shoes in the loading response and initial swing phase. Another same and consistent results are shown in this figure. The results of joint reaction force of subject 2 presents significant differences at mid-stance and terminal stance. When subject 2 walks with shoes, the anterior-posterior hip joint reaction force and the vertical component of ankle joint reaction forces are always below barefoot forces. On the contrary, when subject 2 walks with shoes, anterior-posterior component of knee and ankle joint reaction forces are always greater than the barefoot forces.
From the results, it can be inferred that the medial loading increases in the early stance phase when walking barefoot. When the subjects walked with traditional shoes, the medial loading on the lower extremities is lesser due to the cushioning provided by the sole, which in turn reduces the heel pressure at initial contact. Lower joint power and moments were also observed for subjects while walking with shoes. Both the subjects also experienced higher anterior-posterior knee and ankle joint reaction forces and lower anterior-posterior hip joint reaction forces while walking with shoes. This can be justified by relating it to the muscular force that is required for effective push-off. With shoes on, more force is required for effective push-off. These observations match the observations found in the previously published literature. Few other observations noted was the increase in ankle moment for both the subjects towards terminal swing phase of the gait cycle. The trend of the knee power graph also did not match the trend of the graph found in the literature, although both the subjects displayed the same trend. Different people have different gait patterns. This could be one possible reason why the above trends were observed. Another anomaly observed was that the subject One experiences larger knee movement in the early stance phase while walking with shoes. Subject 1 took fewer steps before hitting the force plate. This could result in a larger knee movement in the early stance phase compared to Subject 2. According to literature, the joint angles decrease by a small amount while walking with shoes on, but both the subjects in this experiment had varying joint angles with and without shoes on. The limitations of this study mainly lies in the number of subjects tested. 2 subjects are not enough to come up with trends that matches the published results. Another limitation was that the participants were males. Meanwhile, the literature had predominantly females, and gait patterns are known to differ between genders. Also, Subject 1 took lesser steps compared to Subject 2, which could be a reason for changes in the trend of Subject 1. Although the differences between the 2 kinds of walking are not significantly big, over time, cumulative loading on these joints can result in deterioration of joint mechanics and could even result in injury. Minimalist barefoot technology is mainly being adopted by runners due to the more natural feel while running and lowered collision forces. Clinicians must be cautious while recommending this to runners because injuries are observed in those runners using minimalist shoes. Future work must involve more researchers to compare the frequency of injuries found in minimalist barefoot technology users with traditional shoe users.
Through our findings, we cannot conclusively support or discard the benefits of MBFT. However, our results do support the idea that MBFT may heighten the risk of injury. Although there is a rise in the interest in barefoot running experiences, people must be aware of the potential risks it carries as well. Thank you for listening.